My name is Tejas Kumar. Tejas, that's how you spell it. I'm not going to say like contagious because that's for the white people on the other side of. This is home. Yeah, you can clap for that. This is home. And here people actually pronounce my name. I don't have to explain it. It's beautiful. And over the years, I've had the privilege, the honor of working hard and working with some of the greatest people in various capacities at some of the greatest companies. I've just learned so much. And I want to share with you some of that stuff. It's not exhaustive. Some were short stints, whatever, but there was learning at each one. Today, I'm a developer relations engineer for Gen AI at Datastax. I literally just get to play with AI all day, every day, and then teach people how to get the most out of AI in production today and how to take it forward to tomorrow. But we're not here to talk about me. This is not the Tejas show. Unfortunately, it has been between the talks. We're here to talk about how we can make AI better with React, right? And a lot of people think, AI better? What? AI is great. AI is so powerful. ChatGPT can speak like a Malayali. Like, how can we make it better? And like the truth is, without React, this is my thesis. You can tweet this, whatever. Without React, AI would suck. Without React, AI would not be as powerful and as useful as it is today. People say, oh, is AI going to replace us? Is React going away? React is what makes AI as good as it is. And so what I mean, yeah, you can. What I mean by that is ChatGPT, right? OpenAI created GPT-3, the model, the large language model. For those of you who don't know what a model is, we'll talk about it. It's just a bunch of weights. It's a bunch of parameters, numbers. It's just a big matrix. That means nothing to the whole world except some researchers in some lab behind academia. People with degrees and people who have some big pedigree. People who have access to information and top quality schools and education and all of this. So they released this model and nobody cared. And then they put React on it, created a chat user interface, called it ChatGPT, and then we know what happened. So without React, we wouldn't have ChatGPT is written in React. And so this is what I'm here to tell you today. We can use React today to take AI to the next level. And in our time together, I'm going to teach you how we can do that through some real code examples and real world applications, okay? But before we do any of that, let's talk about AI. Who here knows what AI is like actually? Oh, come on. You can give yourself some. Okay, cool, yeah. AI is a very misunderstood term. We'll talk about it in a little bit of detail. But before we talk about that, we need to do one level forward. Oh no, there's a timer. Is this what you guys felt like? Let's talk about the job title AI engineer. What is an AI engineer? Anyone an AI engineer here? See, I've been traveling the world. This is conference number 17 that I'm speaking at this year. And I've been asking people, do you think you could be an AI engineer? Do you think you could maybe have a career in this? And people usually answer with no, kind of like you. They're like, I don't. And they don't even say no confidently. They're just like, I don't. And so I'm like, why? What's stopping you? And they say, oh, well, I don't know Python. I don't know linear algebra. I didn't study machine learning. I didn't go to university for this. People think AI is something it's not. I'm here to tell you today clearly what AI engineering even is. And so I'm not even going to use myself as a resource. You shouldn't really trust me. You should do your own research. This is a blog post by my friend Swix. Some know him as Sean Wang. He has a podcast and a blog and a website called Latent Space, where he wrote this beautiful article. It's titled Rise of the AI Engineer. And in this article, he goes on to describe what an AI engineer is. If I zoom in here, he has this diagram. There's machine learning research, machine learning engineering, a big line for the API, and then the AI engineer, and then the full stack engineer. This is how we should think about AI engineering, right? It's behind the API, it's through the API to machine learning models and research. And so with this, what that means is, if you know JavaScript, if you know how to call fetch in JavaScript, you can make a network request to OpenAI, you're an AI engineer. I want you to know that. That's what it means. And so you think, okay, but Tejas, that's devaluing work. No, that's just what it is. I'm not an authority on this. You may think I am. Maybe to some of you it's subjective. But I'll tell you who is an authority. This person on the bottom. Andrej Karpathy was the co-founder of OpenAI. Right? Literally made ChatGPT. And so if anyone can say this, it's him. He says in numbers, there's probably going to be significantly more AI engineers than there are machine learning engineers or large language model engineers. And this last sentence is so powerful. He says, one can be quite successful in this role without what? Without ever training anything. You don't need Python. You don't need data science. You don't need algebra. You just call an API, what is engineering anyway? It's problem solving. If you can solve a problem with a network request to a large language model, you're an AI engineer. Now, if I ask you again, could you be an AI engineer, what would you say? Yeah, okay, great. This space is trending and new, and I need it to be accessible to everybody, because here's the deal. Growing up, a lot of things were not accessible to me, and I had to fight for it. There was a lot of gatekeeping and I don't have a degree. You have any idea how hard it is to move to Germany without a degree? Still, I want to make this accessible to you so we can all play in the space. There is room at the table, okay? Now that we understand AI engineering, let's talk about AI. What is AI? AI is not new. AI is very old. I grew up playing a video game called Mortal Kombat. Children shouldn't play this game. I played this game. It's very gory. There's lots of blood. Anyone fatalities? Yeah, okay. It's nasty. But this is an example of AI. It's an example of what is called rule-based AI. The rules are known by the programmers ahead of time, and they write if statements. If this, then that. They're artificially intelligent. They simulate intelligence, knowledge. It's AI. It's totally AI. But there's also other kinds of AI. There's predictive models. Some of you may have heard of Markov chains. The team at Tata 1MG was talking about Markov chains. A Markov chain is a mathematical model that can predict the next state based on the current state. So using a Markov chain, you have a list of all the weather states, rainy, cloudy, sunny. You can predict tomorrow's weather based on today. But it's limited by what is called the Markov property, meaning there's no memory. You can predict the next state based on this state, not all the states. And so it's very limiting. An example of predictive AI, aka Markov chains, is in your phone. So above your keyboard, you have suggestions for words. Have you ever played this game where you just tap the word repeatedly? Does it make sense in the end? No, because that's a big Markov. It's memoryless. It doesn't know the context of what you're trying to say. It just guesses the next word based on the current one. It's kind of useless. That's why predictive AI didn't take off. And finally, you have deep learning. Deep learning, the rules are not known ahead of time, but the computer uses an algorithm that literally models the brain, neurons, to figure out the rules. How do you get from A to B? Deep learning is the AI that's hyped, particularly this one architecture called the Transformers architecture. This is a paper published by Google Brain, which is a team of scientists, and one other person and the University of Toronto, but mostly Google. And this paper, it's 11 pages, it's very easy to read. In this paper, what they talk about is a new architecture for machine learning models where they can model attention. Not just attention, algorithmically model attention. And not just attention, but multi-headed attention, meaning they can pay attention to a word, it's called an input token, so an input token, but also the surrounding tokens. And they can pay attention to all words and their context in parallel. And this is the way they train the model. This is how GPT-3 was trained. And based on this architecture, we have what is called generative AI. And the reason it's generative is because it makes new stuff. In the architecture is what you call a feed-forward nonlinearity layer, whatever that means. It just means randomness. You introduce a little bit of randomness to create hallucinations or novelty, new ideas, right? And so that feed-forward layer is what makes all this possible. This is all machine learning lore. You don't need to know this, but we've finally arrived at where the hype is. Gen AI, generative AI, through deep learning and the Transformers architecture, which, by the way, I would call the Transformers architecture kind of a misstep if you're thinking like a capitalist, because Google released this and then ChatGPT appeared and now Google's in trouble. If they didn't release the paper, then they maybe had a chance. In any case, Gen AI is not perfect. Does anyone know any problems with Gen AI? You experience some issues? Yeah, what? Decaffeination? There's many problems with Gen AI. Nia, very eloquently, the first problem is hallucinations. My slides are out of order, but hallucinations. Hallucinations are where they see things that are not there, like us, right? Google has this AI overview feature where you type a search query and it gives you an answer, and sometimes the answer is nonsense. People typed in, how many cigarettes should a pregnant woman smoke per day? And just so you know, the answer is 0. Also, if you're not pregnant or a woman, the answer is still 0, but I don't judge. But Google was trained on also jokes. And so it answered with authority that a pregnant woman should smoke between 3 to 5 cigarettes per day. It's a huge problem because people may believe this. And so hallucinations, big problem. Second is that the training data has a finite date. GPT-4 is trained until April 2023. After this, it just doesn't know stuff. You can't get tomorrow's weather. You can't use it as an assistant to should I take an umbrella? I don't know. I don't know tomorrow's weather. And finally, it has a length that is, it can't maintain context. So it's good for up to, like Gemini, the largest model from Google, has a 2 million token context window, which means it can keep about 2 million English words. A token is roughly an English word in context. After this, it starts to give you unreliable results. These three problems all can be solved with one solution. The solution is called RAG. How many of you have heard of RAG? Show me your hands. Okay, good, most of you. Great. RAG stands for Retrieval Augmented Generation. And since many of you have heard of it, I'll just show you RAG in practice. Fun fact, because of the limitation of like current information, even ChatGPT needs RAG because the model itself doesn't know stuff. And I think it was today or fairly recently, ChatGPT released this feature, which is basically RAG. RAG is, it's just, if you think about English, retrieve, so get data, and use it to augment or change the generated output. So you get current data, you put it in your prompt, hey, here's the current data, now generate text. And this happens with ChatGPT. So I'll turn this on, and I'll be like, what's the weather in Goa tomorrow, right? And look what it's doing. It's searching, it's retrieving, it's including the search in the prompt, and now it's going to give me, so there we go. As of this time, the weather is this. And so this is RAG. It's getting context and augmenting the output. RAG is the most powerful technique for real-time information with GenAI. It's used everywhere. Let me show you. So I built a project with RAG, actually. So I have a podcast. Some of you actually so nicely told me you listen to it. The episodes are very long. Not everybody has time to listen to all of this. And so in the podcast, I have this feature where you can just search for stuff. If I come here, this is the podcast. And people can just like learn anything from every conversation we have ever had, ever, with GenAI. And you can see it. So let's say, how do you balance work and life with a family? And if you hit enter, it will search across every conversation I ever had. And you can see that we discussed this at this time with Kent C. Dodds and other things. And then if I click on this, I'm taken to exactly that point in time where he says, watch the subtitles. How does one then balance family with 5 children? And so Kent then gives me the answer. Incredible. Say you have other questions, like I'm living in the slums. How do I become a GDE, right? Oh, excuse me, GDE. Some people maybe want to find a way. What should I learn? How do I do it? And you can actually learn from a world expert, Santosh Yadav, who was a speaker at the conference. You click on this, and you're taken to the exact point in time where he says, so that was the time I started making more money, and we moved away from the slums. You see that word? Yeah, amazing. Thank you. So you can actually get exactly what you want. We'll do one more, like how do I file a patent and become an inventor, right? If you just want to know stuff, anything from the speakers you know and love, you just do this. And Shruti Kapoor right here, she spoke yesterday. And just like that, how do you know what to patent, when to patent? And she does it. By the way, I don't know if you know this, but she's an inventor. She has a patent. So anyway, that's RAG in practice. So how does RAG actually work? I'd love to build a little diagram with you to make sure you fully understand RAG. And then with what time we have left, we'll talk about the future with React Server components and how we can make it even better, okay? So how does RAG work? Well, if we consider just a regular AI application, you have a chat input, right? You have a chat output. So let's get a chat output. Let's put it here. And in between, let's zoom out a little bit. In between, you have an LLM, or a large language model. So we'll go to models, and we'll choose OpenAI. OpenAI is pretty much the go-to. And so now I'm going to choose a really cheap model, GPT 3.5 Turbo. So my chat input, I'll just connect it here, and I'll connect the response to output. And so now I can come to my playground, and I can just ask a question. Which movie won the Oscar for Best Picture in 2024? The problem is I'm asking GPT 3.5 about 2024, and the answer is kind of useless. This is AI without RAG. I'm not retrieving any real-time stuff. It doesn't work. And so how can we do RAG? What is RAG? In practice, how do we build it? Let's zoom out and show you. So we'll introduce some distance between the input and the model. Can you all see the text for the components? Okay. So let's put some steps in between. First, we need a vector database. So I work with a company that makes one. You don't have to use ours. You can use whoever you want. But we make AstraDB. You need a vector database because you need to retrieve like relevant results. Then you need an embeddings model. An embeddings model is a specialized machine learning model that can translate natural language, so English, into numbers for comparison. And we're just going to connect the chat input to the search input of the database and the embeddings model. We're just drawing a little diagram, okay? Now, we get some data from the database. What do? Well, we get back JSON, but we need to parse it into a string. So I'm going to get parse data, and I'm going to just take it here and connect my search results to the data. So now I have all the data from my database as text. And this is where the RAG magic happens, because I'll construct a prompt. This is prompt engineering, in case you wondered. So what we're going to do is we're going to get a prompt component. So we'll go prompt. And I'll get a prompt. And what you can do with prompts is actually quite cool. You can create variables. What I'm about to show you is the most classic RAG prompt ever. This is what it looks like. Given this context, and we'll do context, that's a variable, answer the question, and we'll say question. Now, context comes from my database. Question comes from my user. And so if I check and save, this is good. So now what I'm going to do is literally do that. Context comes from my database, and question comes from my user, just like this, right? And now I take this prompt, which has both context and the question, give it to OpenAI, and that's it. My RAG flow is ready. In case you're wondering, this tool is called Langflow. We make it. It's open source. It's free. We don't like. You can self-host it. We also have a serverless thing. So now let's go to the playground and ask exactly the same question again. So, I'm going to hit enter. Okay, it's good. It's actually helping me. I forgot to choose my database. So I'll choose my right database. It's called Oscars. There we go. And I'll run it again. I think really the mark of a good system is it tells you like what's wrong. Anyway, so let's hit play. And now it's going to look up the information in our database, put it in the prompt, and just like that, it's going to tell me Oppenheimer won the Oscar. Look at that. We fixed all those problems. Thank you. That's visually how RAG works. Now, we could do even better. We could be like, tell me more, right, about the Oscars 2024. And let's see what we get. Oh, I have to scroll. And what we get is just a bunch of real-time 2024. This is past the knowledge cutoff. This is not hallucinated. In 2024, Oppenheimer was the big winner. It got 7 Oscars. It was by Nolan. All of this is right and true, and we know that because our data is true. RAG makes LLMs useful for production workloads today, right now, with real-time data. That's what I want to teach you. You can build this like right now. In fact, Tata 1MG is doing some great stuff with that already. Really crack team. Okay, so that's all well and good, but it's an intermediate step because I'm doing this. This is great. How do I get this into my React app? This is React India. Well, with Langflow, this whole flow now that I modeled, there's this API button. And if I click it, it literally just becomes an endpoint. And I call this URL, and I can use it in my front end. It's absolutely bananas, okay? I want to switch a little bit and talk about user experience and React server components, because that's why we're here. I don't know about you. I am tired. Wow. There's a drone. That's cool. I'm tired of chatbots. Anyone else tired of chat? I think we're kind of done. I'm not into, like I use Cursor and Claude. I don't use chatbots, you know. And so I think we can do better. And this is where I want to talk to you about generative UI. Because generative AI is cool. We saw that. How might we do generative UI? And let me just show you instead of tell you. Now, I'm a little bit biased because I did spend some time at Vercel, but I'm going to show you the Vercel AI SDK. Anyone using this? Yeah, almost. Okay, like 5. And so I'll show you this. To show you the power of generative UI, I built an app. I built an app out of frustration because I search for movies like a regular person. Like if I'm searching for a movie with a story in Goa, I type that. I don't know the exact name. I'm not a machine. So when I'm trying to watch Netflix, let's go to Netflix, choose Tejas. And if I type, this is literally Netflix, right? And I'll type like movies with the story in Goa. And I get I get no results. This is kind of annoying. And look at the first suggestion. It says try different keywords. I'm not going to type the right keywords. I want to get the feel of the movie. And so I built an app that is a proof of concept, actually a research project, that's like, what if Netflix actually used Gen AI like nicely with search, which I love Netflix, so there's not a knock against Netflix. They actually, I think, a customer. Anyway, so let's look at and then we'll look at the code of how it's built. So this is it. It's called Movies++. And I will actually go copy my search query from Netflix straight into Movies++. So I'm not even changing, and so I'm going to hit enter. And now it's going to search for movies. And it's okay, sure, it gives me text. And are these actually, like, did they have something to do with Goa or not? Okay, cool. So it's already working, but it's a chatbot. It's text. I don't like it. What if we can do better? What if we might say, what might this look like as UI, you know? And now, look at that's so much better. So much better. And so I can see that it's interactive. So these are server components. And we'll talk about the technical details in a minute. But beautiful. Okay, so I can now click it and I can see the movie. I can see the details and so on. But let's go back. And I'm really thinking about like watching Dear Zindagi. That looks cool. Did people like Dear Zindagi? You know, I could do something like this. And it picks the right format, right? It's going to show me text because how else do you express this besides text? And now I'm still more interested in the movie, so I might do something like show me the trailer for Dear Zindagi. And it's literally like, look at this. It's going to start playing the trailer like right here. And I think this is just absolutely bananas. Yeah, thank you. It's like so much more valuable. It really helps me. Now I want to watch the movie. I'm like, where can I go to watch movies? And this is where it gets like really crazy because I hit enter. My browser asks me for permission to share my location. And I click allow, and like, look at this is Planet Hollywood right here, and we take a car and go to Novelty Cinema, and we can find movies. That's absolutely. And you're telling me chatbots, you know? We can do all of this is React. All of this is the power of streaming from the server side, and we'll look at the code in just a minute. I want you to you usually use chatbots for support, right? Like user support. And usually, I don't know about you, but for me, I'm like, when can I talk to a human? They will get me. And usually it's when I forgot my password, or I need to do something. What if the future of support looked like, you just do, I forgot my password, and you hit enter, and instead of some long documentation, you just get this, fill out your new password, you're good, right? Thank you, yeah. This is what you can build with React. Now, I started the talk by saying, without React, AI is kind of okay. React is the secret sauce here. Your jobs are safe because this is needed, at least for now, okay? And so how is this built? How is this built? Well, as a human being, think about it. If you ask me to multiply 3 prime numbers, I will fail. I'm not good at math. That's why I use AI, which is also not good at math. But in any case, you ask me to multiply like 3 prime numbers, I won't do it. But what I do know is that there's a tool I can use. And I know this tool because of my experience. And so I'll go use the tool. Well, large language models, most of them now, can do exactly the same thing because they are neural networks. And so they can recognize, I need to use a tool, go use a tool. That's how we're doing all this. Let's look at this. So in principle, a tool is a function as code. We write functions, yes. What do we call a function that like returns some JavaScript objects? What do we call a function that returns some JavaScript object with a key $$ type of symbol for React? What I'm saying is you can call a function that returns React components, that returns, React elements. And those React elements you can stream over the network. That's what's happening here. Let's look at this in code. And you can use suspense with this as well. All of this is React. So let's take a look at the code. This is the code. So let's walk through what's happening here. We create an instance of AI. We have a function called continue conversation. Okay? We get AI state, and that's just the conversation history. Welcome, everybody. We stream UI. This is the secret sauce, and we say talk to GPT-4o. Then, if you get back text, just stream the text to the client and just stream Markdown. But the real magic is the tools. Remember, I talked about the calculator, right? These tools are that. They're just a bunch of functions. So let's maybe take a look at the get movies component. What's happening here? So it's got a description which says a tool used to get a list of movies matching a user's query. This is how the LLM knows to call this function because it's good at language. So you read my description, okay, call this tool when the user, and literally will call the function when the user matches. Is this clear? So that's how it knows to get movies. But what else do we have? We have a Zod scheme. Anyone using Zod? Zod, oh, everyone, I love it. So you give a Zod schema to say these are the input properties to my component. So it's not like the LLM or the AI generates the components themselves. I write the component. The LLM creates the props, just the props. That's the magic. So movies just takes a list of movies. The LLM generates that JSON. Is that clear? And it can generate the JSON in a valid format because we're using Zod. Meaning internally, what the Vercel AI SDK is doing is it tries to validate the return from the LLM with Zod, and it fails. And so it just tries again until you get back valid JSON. Then we have this generate function, which is a actual generator with the asterisk, meaning you can yield multiple times. Like, I don't know if you saw that, but if you say, like, show me movies about Bhangra, there's a spinner. You see that? We yield first the spinner, and then we continue. Let's look at that in code. So it's a generator. So first, we console log, and then we yield a React component. It's literally a spinner. Immediately send a spinner. Then we get some chat completions, and then we persist the text state of the UI. But what I want to show you here is we return this, just a markdown list of movies. If we talk about the cover art, let's go look at that other tool, meaning what might this look like as UI. We show a spinner. We it's called this one, create generative UI. So here, what we do is we get a bunch of stuff and we render a component movies. The LLM is not generating this component. So if I click into this component, I wrote all this code. This is my code. This is not prone to hallucinations. The LLM is not going to generate nonsense because I wrote this. And this is really cool because it brings a level of determinism to LLMs. I know that my forgot password component is always going to render the way I wrote it. And the only thing that changes is the props. And so the LLM generates this stuff, right? The movie's title, the poster path, it gets that. And then it's just plain old React. The cool thing is this works with server components and client components. And the Vercel AI SDK takes care of that. But how it takes care of that, I hope it's clear, right? It's using the classic Next.js bundler. So when you experience a use client, it will generate a JavaScript bundle for that and load it on demand, okay? Let's continue. But was this clear? Is there any questions? I mean, if there are questions, we can talk in the break. I'm trying to hold myself to my, my standard of timing. Let's summarize. In summary, we covered a lot of things. We talked about, do you have what it takes to be an AI engineer? You couldn't answer the question because you probably didn't know what an AI engineer is. It's very nascent, it's very new, it's very novel. But then we defined the AI engineer. And then a lot of you, I heard you say yes, this is great. It's a new thing. It feels like the web just got invented. It's the Wild West, but I want to help you play in this space. It's very exciting. From there, we looked at the limitations of large language models, and we solved them with RAG. I hope RAG is clear for you, and I hope you use it. You use that prompt engineering in production today. There's really no reason not to. Finally, we looked at generative UI. That was so cool. Literally asking for the user's location from the browser and building something more than a chatbot, a holistic experience. Now, I could talk about this for hours, and guess what? I actually do. I have a podcast, long, like hour and a half, 2 hours, sometimes with really great guests, many of whom are here, but otherwise, I just do lectures. And if you want to learn more about that, there's the code. I'll give you a second to scan it. Please don't feel pressured now to put up your phone. If you don't scan it, I don't take it personally. Also, you can literally just Google it. This is very unnecessary. But I appreciate that you're doing that. Great. We've covered a lot, and that's it. That's my talk. I want to say thank you so much for the opportunity to give you this talk today. Thank you.